all by now have this booklet, a factoring booklet, okay? So once we're done with all the cases that you can encounter, this booklet will kind of go over all of the possible scenarios you can see, right? So I'll start assigning from this booklet and just keep that handy, keep that in mind. Okay, so we will continue with our notes. And I want to cover, before I move on to the special polynomials, I will just call this factoring trinomials with multiple variables. Okay. Factoring trinomials with multiple variables. When you notice a trinomial with a something squared on both ends, and that's after taking out the GCF, right? Don't rewrite. We factor this trinomial the same way as before. Except for oops, except for the fact that both brackets will have two variables. So some examples. M squared plus hold on, not plus, minus. So let's say you have m squared minus 6mn minus 16n squared. So you notice that front and back, they have a variable that is squared, okay? Obviously, you would try to first take out a GCF, right? Take out, if this front term had a negative, we'd still take it out of the whole trinomial. That's not the case, but don't bother rewriting it. Just leave it like that, okay? Notice that a is equal to 1, right? This is just a multiply sum method. Okay, that's all it is. So c is equal to, right? C is equal to negative 16. So you notice that if c is negative, the two factors that I have will have opposite signs, right? One will be positive, one will be negative. And you need to get a -6 out of that. So I know that 2 and 8 multiplied to 16, I want the 8 to be negative, right? Because if I add 2 minus 8, I get -6, and this is B, right? So that checks out. So you take that over here, just like before, except for it used to be m plus 2, right? M plus 2, because that's the first factor, the first factor that goes in here. But in this case, you have a second variable, so you're going to bring that variable in. You introduce that variable into that. And then close bracket, and then you start your second one, which is m minus 8, and you have to introduce that second variable as well. So it's done the same way as before, except for now you have two variables in each of the brackets. And to make sure you got this right, you still do the double smiley face rule, right? 2n times m is 2mn positive, m minus -8n is -8mn, right? And that adds up to -6mn, which is exactly what you want, right? That's that middle term there, which is over here as well. Two variables, answer looks like number x plus number y, right? And then you have number x plus number y. Like you'll have both variables and you'll have coefficients in front of each of them. And notice that the coefficient for both m's is 1 in this case because this is a scenario where that is happening. Another example. -a squared plus minus 7ax minus 12 x squared So notice again, right? You have the one variable there and another variable there, and they meet in the middle, right? So you know that there are two variables there. And again, remember that sticky note that I showed you yesterday, the steps, right? We still walk through them. You still always try to take out a negative because this leading coefficient here has a negative. We'll take that out for sure. And then look if you can take out a number from all of them or possibly another variable, okay? And in this case, you can. So we'll take out the negative. That leaves you with a squared plus 7ax plus 12 x squared. Don't forget that x squared. A is still equal to 1, right? You make that note. So it's going to be an easier case. You don't have to do the matrix. And then we'll look at C. C is positive, right? C is equal to 12 in this case, and is positive, so they'll have the same sign as B. So we're looking at 2 and 6 would work, but if I add it up, I get 8, right? I want a 7, so I'm going to go 3 and 4. Positive 3, positive 4, that's positive 7, which is equal to B, right? That's exactly what I want. So in this case, not forgetting the negative, right? That's A plus 3 x, don't forget about the x, plus 4x, right? And there you have it. And let's do the quick check in our heads, right? Because you want to be able to go this times this and get 3ax, and on the outside you get 4ax, which gives you 7ax, right? So that's a quick way of checking. It's like, wait a minute, I don't get that, because that's a common mistake. Students forget about putting the second variable in, and then it's wrong, right? It's not the right way. So let's do one where we need to where a is not equal to 1. So let's say I give you this one, 6x squared plus xy minus 2y squared. Make sure you submit the AC, okay? I need a less than a handful still. Unless you're in class, then it's fine. If you didn't bring your phone, then I'll get it. Okay, this has two variables again, right? You notice that? That should, right, ring a bell. And you try to take out a common factor, and you cannot, right? There's no negative in front of the leading coefficient. I'm not going to try to rewrite it because I have the square terms on either end, right? So no need to do that. A does not equal to 1, right? I need to use the matrix method. Okay. I notice that C is negative, so that means that we'll have opposite signs of our factors on the other side of the matrix, right? So I'm going to start here. Factors of A still go here. Factors of B go here, 1, 2. And you notice that you have less options for C, right? Less options here. So you most likely might have to resort to 2 times 3 for the first one. But we'll see where it goes. Okay. One of them has to be negative, so I'll go ahead and do that. I'll make the top negative. So that's 2. That's negative 6. That adds up to negative 4. Doesn't work. Even if I were to make another matrix where I just flip the sign, it would not work. Okay, you get a 4 after all. So 1, 6, I'm going to actually flip the values. And I can see already that that's not going to work either, right? I get negative 12 and positive 1 out of this. That gives me negative 11. Not going to work either. Okay, so now I'm going to resort to 2, 3. 2, 3 and 1, 2, right? I'm going to go back to 1, 2. And I'm going to make this one negative. Because if you're already looking at the big picture, right? There's -4, and this is 3. That adds up to -1. Close, close, but not quite. The sign is off. Because I'm close, all I need to do is rewrite this matrix and just put the negative on top, right? So I'm going to go 2, 3, and it's -1, 2. That gives me 4 and -3. So that's the pattern. Flipping the sign just changes the value of your answer. Flipping the actual number gives you a different outcome, right? A different value altogether. So this is equal to B. I'm happy now. I'm going to go back here, and it gets tricky here, right? Because the coefficient of the first variable will be different. It won't just be 1. So it's 2x, right, minus 1y, right? That's 1y. I can just put down y. Okay, and then it's 3x plus 2y. Okay, and it might get a little messy. I don't know where your matrix is, so you decide. But right, this 2 went into there, and this -1 went into there. Right? And if you want to go different color, maybe, right? This 3 went into there. If my pen would cooperate. Right, that 3 went into there, and this 2 went into there. So really, the way we're doing things is the exact same thing as before, folks. It's just that we have that second variable to watch out for because there's another squared term at the end. Okay, that's all I'm saying here. We're not learning brand new stuff. It's just slightly different, and you will encounter this from time to time. Okay, so I'm going to leave it at that. And now we're going to do the special. These are the last two cases that we're going to encounter. Okay, the last two cases, and then from there we can just, it's a bit more of a review, see if you can navigate and identify which one is which.